I'm Prashant Kulkarni. I'm a lead AI security research engineer here at Google Cloud. I'm passionate about building secure, scalable, and responsible AI system, and that's what I'll be talking today. I wish I could be there with you, but I'm happy to be able to share the idea right from here, Sunnyvale. All right. So, as you know, we are witnessing a revolution right now, a transformation that's going to go far beyond just the text. So think about it. AI has already revolutionized the field, like protein folding with AlphaFold, as you guys know, right there in London, dramatically accelerating drug discovery. NVIDIA's Earth 2 platform is pushing the boundaries of weather prediction, giving us unprecedented insights into climate change. Google Cloud and Swift have teamed up to develop a secure privacy preserving solution aimed at helping financial institutions combat fraud. And I just chose these three examples, but to truly realize this transformative potential of AI, we have to address certain fundamental challenges of accessing and utilizing data. Do you guys know, you probably know, 90% of the world's data is private, right? So we are sitting on a goldmine of data, but it's locked up in silos, blocking progress and innovation. Typically, regulations and privacy concerns are at the top that restrict access, stalling scientific breakthroughs, and creating competitive disadvantage. Now imagine how much faster these breakthroughs could have been with more accurate and personalized this application could be if researchers could have tapped into diverse private data sets without compromising security. So that's what we are doing, federated learning on steroid, right? So we are seeing an opportunity and a challenge. The explosion of distributed data creates immense potential for AI, but traditional method of training raise significant privacy concerns. Google Cloud see the need to provide solutions that enable innovations while safeguarding data. How do we reduce the friction for developers and organizations? We need a way to make it secure by default. To support a safe cloud journey, we provide extensive range of security tools that can be represented as policy as a code as well as directly configured. Now, let's be honest, like all the technical jargon and all the product names that you saw are just difficult to remember. You forget about reading them, right? So what everyone cares about can be summed up pretty easily as far as Google goes. We focus on these 3 points. First, do you guarantee the privacy of my data? Do you comply with the data sovereignty regulations? These are fundamental trust requirements. As far as security control goes, we often get asked, what specific controls do you have in place to protect my data? From encryption and access management to data exfiltration, prevention, and auditability. And this is what Google does the best. Google Cloud Security isn't just a collection of tools as you saw in 2 previous slides. It's built on some core principles, starting with zero trust, where we always verify every user and device. We enforce strong IAM controls, giving you granular control over who has access to what, a crucial component for zero trust. And finally, data is encrypted by default, both in transit and at rest. And we provide Security Command Center for comprehensive threat detection and vulnerability management across your environment. And with our recent acquisition of Wiz, this is only going to get better. All right, so now let's talk about federated learning options on Google Cloud. We are focused on building scalable and secure collaborative AI solution. First, we have Rhino Health. We just saw Rhino Health's amazing presentation. Love that product. They're doing some great work with us in healthcare space, leveraging federated learning to train models on sensitive patient data. Then there is NVIDIA Flare, which you saw all day today. Amazing presentation from Holger. As you can see at the bottom of the slide, both Rhino and NVIDIA actually support Flower. And this highlights Flower's versatility and its ability to act as an unifying layer across different platforms. That's what we like the most about Flower. Flower makes a natural choice for Google with its open source capability. And Google Cloud customers want a flexible and powerful federated learning framework. Now let's take a look at how we work together. This is a slide that shows GKE, Google Kubernetes Engine, a managed Kubernetes service on Google Cloud for our federated learning setup. GKE is a top choice for training many LLM labs on Google. On the left, you see Google Managed Portion. So this takes away the pain of managing GKE. Google does that for you. Now on the right, we have the Customer Managed Portion. This is where your federated learning workloads run. You will see 3 GKE nodes here. These nodes are where the pods run, and importantly, in this case, those pods are our Flower modules. Now think of these pods as individual Flower worker. Each pod is responsible for running a part of federated learning process. Now this can be scaled out further, so let's take a look. This slide shows a global architecture for Flower on GKE. These are GKE clusters running Flower client that run in various geographical regions of Google Cloud. Flower server is hosted in North America, coordinating all the training. Now, sorry, this is a very busy slide, so now let us zoom in. Now here you see 2 main things. There is a VPC peering from a North America project to an EMEA project. The peering is only done at a project level for the purposes of training. As you know, Google Cloud typically has a structure of a Google Cloud org and a project underneath. So we are only peering the VPC at a project level. This gives the GKE cluster from the North America project ability to talk to the GKE cluster in EMEA via the GKE multi-cluster services. The MCAS feature of GKE extends the reach of the Kubernetes beyond the cluster boundary and lets you discover and invoke services across multiple GKE clusters without compromising security. Now, talking about security, this is how it shows up on GKE dashboard. So we call this a GKE security posture. It is designed for platform and security teams looking after the training infrastructure. It focuses on securing GKE cluster and compute infrastructure. It does not replace the need of application security and network security. Those are that are part of the solutions, overall security solutions. Here you see a security dashboard of various aspects of GKE cluster and federated training workload. I love this for the reason that it makes the job of security engineer supporting the fine-tuning team and training team so much easier. All right. So before we jump on the demo, my plan is to show you guys a recorded demo. I chickened out on a live demo and show you Gemma 3, which is one of our open source model that is actually making waves. We're going to fine tune this on Flower on GKE. So the core value proposition here is federated learning without compromising any of the user data privacy. So this essentially lowers the barriers to entry for fine tuning large language model, making it accessible to a wide range of developers and organizations. Now let us go to the fun part. Let's see Gemma 3 fine-tuning in action. I'm going to use Maxim Lebo's fine-tuned dataset. Who's Maxim? Check out his beautiful book on LLM Engineer's Handbook. I'm sure you'll be a fan of him too. All right, let's see the demo now. Let me know if you guys hear the demo properly and see it.
All right. Okay, let's dive into a quick demo.
We hear it.
Okay.
Federated fine-tuning Gemma 3 using Flower. We are leveraging parameter efficient fine-tuning to make this process efficient and scalable. So here is the setup. We are working with Gemma 3 4 billion instruction tune model, quantizing it to 4 bits for memory efficiency. We are using LoRa with a rank of 32 and alpha of 64 to focus the fine-tuning. We are going to tune 7 layers of the model. I'm going to quickly walk you through my GKE cluster configuration. Here is my cluster for fine-tuning Gemma 3. This is the cluster dashboard. This is the cluster dashboard showing various aspects of GKE. Let us check the security dashboard as well. Here is a quick shot at the overall security posture of my cluster. There you should see top 3 concerns in the workload configuration. If I scroll down, you will see threat detection. This cluster is a standard cluster as opposed to a GKE enterprise cluster being a POC, so you don't see much, but you get the idea. Now let us go command line because that is the best way to work. Am I right? Now let's verify that the nodes have GPU enabled. I'm going to run a NVIDIA SMI command. You can see the GPU is detected. So NVIDIA SMA is happy, we are happy. Now let us see pods. As expected, we have 6 pods running. You can see here. 1 superlink, 2 supernodes, 2 client apps, and 1 server app. My Flower configuration is set to run minimum 2 client apps, hence we need 2 supernodes. Now let us see Kubernetes service. Now you can see here the services. The important point to see is superlink being set as a load balancer. Now let us start the workload. I'm going to use my Linux desktop to trigger it. Here, so let's trigger it. So this is now starting a Flower run to fine-tune Gemma 3. Now you can see we are streaming the logs from the container. So now let's go back and see what the client app is doing. This command gives me logs of client app. So client app is still waiting. So let's go see the second client app. There you go. So it is actually fetching a partition of the data set. We should see that on client 1 too. There you go. Now it is actually creating a generating train split for the data set that we talked about. Now on the desktop side, we should start seeing progress. There you go. Now we start seeing round 1. So Flower is doing its magic. And you can actually see here, so the target module 1, 2, 3, 4, 5, 6, 7, 8. Actually, in fact, we are doing 8. We are targeting 8 modules for performance fine-tuning. Now, at some point, this will finish. So we'll come back and see this finished. 10 rounds are finished, and you can see now the summary of the rounds. Now let's go check on the server app where we should see an aggregated model from the clients. So let's log into to the server. Alright, we are on the server container. So let's check. So as you guys know, the model is produced under results. So we are under /app results, and you can see the model is produced here. So let's go check. And we take checkpoints, so let's check the last one. And here is the LoRa model.
All right, hope you enjoyed that demo. So let's go back.
Okay, let's dive in.
All right. I wanted to throw some fun fact to you about GKE. GKE is a massively scalable application, so it can scale up to 65,000 nodes. In my demo, I only use 3. And another fun fact is Google ran largest training cluster on GKE with 50,000 plus TPU for one of the training runs. So this tells you how much scalability can be achieved with Flower on GKE. Now we have seen so far Flower and Cloud on Google Cloud are empowering the future of federated learning, particularly with the use case like LLM fine-tuning, which is going to get a lot of attention. I invite you to explore our open source repository on GitHub called Accelerated Platforms. This is our blueprint. You should also shortly see Flower embedded into that repository. Right now, I believe there is an NVIDIA flare. We would love to work with you, so connect us to discuss your projects, and let's build the future of federated collaborative AI together. Thank you. And I'm happy to take any questions.
That was wonderful. We're going to set up for the panel, but while we do that, we're going to take a few questions. I'm sure there's a few people who want to ask you some things. Any questions? I had one. I was wondering, what would you be most excited to see someone fine-tune Gemini to do? Assuming you have access to all this private data, you mentioned that 90% of the world's data is private, right? So it's a lot of data. What strikes you as an exciting possibility there?
Yeah, so recently I visited my doctor, and my doctor told me, hey, some other doctors are using this AI, but I don't trust it yet. And that's what I would like to be changed. With fine-tuning, you actually get really trustworthy and grounded answers. And someone like doctors, who traditionally have not used AI to do any of the work they do, I'd like to see that mindset change.
Any other questions out there? No? Okay. Well then, yeah, sorry.
Hey, thanks a lot. Thanks for the demo and the talk. I'm wondering, you mentioned the 50 plus thousand TPUs. Sounds cool, but that kind of triggered a question in my head. What would be the cost model? What is the cost model of let's say the demo that you just showed, right? So how does it work?
Yeah, so I use on demand basically. I was using A100 40 gig, and they're charged by hours. But typically, when you have a large infrastructure, you do a commit for a year, for 3 years, that kind of commit, and that actually brings down your costs substantially. So rather than using hourly pay-as-you-go model, you actually do a commit. You also have an option to use spot instances on Google Cloud, so that reduces further the cost.
We're just getting started with what we can do together. I think your presentation is a great reminder that the best is yet to come. So thank you so much.